F is continuous for x is in between a and b, so you got some weird interval going on, but not differentiable for some c. So you can't take the derivative at c, and c also lives in between a and b. So you got x living in between a and b, you got c living in between a and b. So basically you have x equals c, some point that you're going to plug in. It's not differentiable at that point. Which of the following could be true? All right, so we need to find out which one of these is true. So if it's continuous on A to B, A says x equals c is a vertical asymptote. That is not true. A vertical asymptote implies that it's not continuous, and it is continuous, so A won't work. The limit as x approaches c of f of x can't equal f of c. That's not that's also not true because that also implies discontinuity. You can't have that either. The graph of f has a cusp at x equals c. Well, a cusp is a point where the function is continuous but not differentiable, right? So c is going to be my guy for this one, okay? F of c is undefined, would imply again, some kind of asymptote or something like that, and therefore it's not none of the above. So c is the only one that makes sense, again, because a cusp is a point where the function is continuous but not differentiable. Which of the following functions is not differentiable at x equals 1? All right, well, things that are not differentiable are when you have a cusp or a sharp corner at that point. If I were to graph A, okay, there's no sharp corners anywhere. If I were to graph B, it looks like this, but more importantly, it looks like this at x equals 1. At x equals 1, I get a sharp corner, which means B is my guy that's not differentiable at x equals 1. C is a cubic, you're a line. All three of these guys are differentiable everywhere, but B isn't because of that sharp corner at x equals 1. The graph of f of x shown above consists of a semicircle and two line segments. There's my semicircle, there's my line segments. F prime of 3 equals what? Well, f prime means derivative, and the derivative means slope. So if I go to 3, the derivative at that moment appears to be a perfectly straight line where the slope is a positive 1. So my answer is D. So that's basically it. I mean, you're basically being asked what is the derivative at that moment. What is the slope at that moment? 3, and my slope is 1 right at that moment. That's it. For the function f of x equals the square root of x, where does the derivative fail to exist? Well, with square roots of x's, you're looking at a graph that looks like this. Okay, like that. All right. Now, this is continuous from 0 all the way unto infinity. However, wherever you have a cusp or a sharp corner, it's not differentiable, which means if it's not differentiable, you can't take the derivative. Right here at the very beginning at 0, you have a cusp, which means it fails to give you a derivative if you have 0. Now, again, if you were to, I don't know, I don't believe you, then do this. You take that and you take the limit as h approaches infinity. You do that whole thing and plug in 0 and find out that it's not going to be able to be done. But in this case, if I see graphically that there's a cusp or a sharp corner at a specific spot, the derivative will not exist, and that happens here at 0.